Okay, so today we're going to finish up this section. Okay, there's not much left in there. We're going to learn how to solve these on a calculator. And we're going to learn how to graph things that aren't square roots. We're going to graph cube roots. Woo! Too, yeah, scary, amazing stuff. Okay. So you don't necessarily need to get a calculator right now to do this. You can just kind of watch along with me. No, just sit back and enjoy the show for a little while. You've done this before. You've done this enough times already to kind of know what the deal is here. Okay? All right, so it says, you can model the population P of Corpus Christi, Texas, between the years 1970 and 2005 by the radical function P of x equals 75,000 times the cube root of x minus 1950, where x is the year. Okay? So using this model, in what year was the population of Corpus Christi? 250,000. So we don't actually have to do this with a calculator, but we're just going to just because it's so much fun. Okay? How would you do this algebraically?
Are we reviewing now?
No, we're finishing the last section in the chapter. What would I plug in for the y?
225 or 2000.
250,000, right. So if I wanted to solve this algebraically, since the population is 250,000, I would plug that in for the population and set it equal to 75,000 times the cube root of x minus 1950. Okay, then what do you want to do? Divide both sides by 75,000. So if I go 250, 1, 2, 3, divided by 75, 1, 2, 3, then I get, what's 3.3 repeating? 3 1/3. Very good, children. So that would be 3 1/3 equals the cube root of x minus 1950. How do I get rid of the cube root? Cube both sides. So if I go 3 1/3 cubed, then I get, 37-ish. So 37 equals x minus 1950. And then how do I get rid of the 1950? You add it to both sides, so x would equal 1987, okay? So we can do this algebraically, but the textbook authors would apparently like to make sure that you could do these graphically as well. So here's how you do it graphically. You, in y equals, you type in that population equation for Corpus Christi. So I'm going to go 75,000 times the cube root of, how are you going to do cube root?
X to the 1/3.
You could do the whole thing to the 1/3 power. That would certainly work. Okay. Right, we have a cube root thing under the math menu. If you hit math and then number 4, that'll give you the cube root. But what you said will also work. So that's going to be the cube root of x minus 1950. Okay? But then the hard part of this is that you have to find a viewing window where that graph will show up. And so we did this second period and we dorked around a little bit and we found a window where if I make my x minimum 1970 and my y maximum 2005, did I choose them randomly? No, it says specifically in the problem that this is for the years between 1970 and 2005. So that's what we use as our x's. And then the y's, if this population here is 75,000 and I want to go up to 250,000, we sort of use that to guide our choice of the y minimum and maximum. Okay, so that let me see the graph. What do I do to find out when that's 250,000? Good, I have a second equation, and what is that second equation, Colton? Right, just simply y equals 250,000. And then when I graph that, I want to see where those two graphs cross. Do you remember how to do that? Second trace 5, because that says intersect. And then it's asking, is that the first curve you want to check? Yes. Is that the second curve? Yes. Is that a guess where they cross? Yes. And so you we get the same answers when we did it algebraically in 1987. Okay? So sometimes it's easier algebraically. Like I think your very first problem on your assignment tonight says to solve by graphing, but it's much easier just to solve it using algebra. But then the second one is some crazy word problem thing, and that's probably a little bit easier to do on a calculator. All right? You good with that? All right, what would we want to do? What would we need to do to find out when the population of Corpus Christi was 275,000?
Same thing, but it's just.
Right, same thing, but I would change the 250,000 to 275,000. Okay, and then I would find where they cross. All right, so that's not a big deal. Then the other thing that we need to do is we need to take a look at how to graph cube root functions. And the good news is that it's pretty much the same as graphing square root functions in that all of the stuff that you do with multiplying and the shifting and the stretching is all the same. But what we do need to know to start with is what your basic cube root function looks like. So give me a point that you know, give me a number that you know the cube root of. 0. What's the cube root of 0? 0. So just like the square root function, that's going to go through 0, 0. What's another number that you know the cube root of? 8. All right. 1, 2, 3, 4, 5, 6, 7, 8. The cube root of 8 is 2. So that point is also going to be on the graph. What about a number in between 0 and 8? What about a number between 0 and 8? What about a number between 0 and 8? 1. The cube root of 1 is 1. Okay? So for the square root function, the cube root function, they look the same when we're starting because they both go through these points. But whereas the square root function, you would go over to 4 and then up to 2 because the square root of 4 is 2. For the cube root function, it's a little bit flatter because, like you guys said, the next number that you know the cube root of is 27. So I would need to get all the way out here to 27 before I go up 1 unit. All right? So it's a little bit flatter than the square root function. What else might you think would be different about the cube root function? What? Right, we can take cube roots of negative numbers as well. So if x is -1, what's the cube root of -1? -1. Okay?
So instead of just going this way.
Right, it's like if you went like this, but then you just flip that part over to here. Okay, because then the other one that we would know would be -8, -2, 3, 4, 5, 6, 7, 8, -2, and so this is going to look like.
So when we're solving that equation with the cube root, do we have to do the plus or minus cube root, or will it tell us?
No, we only do plus or minuses on even roots. All right. Okay, so that's our parent cube root function. Okay. Now we're going to
Why are we learning this? We're not going to use it.
Couldn't you say that about anything that we have learned in this class?
Exactly.
So why are you learning this? You tell me. You show up here every day.
Well,
Well, that's because they told me that they hired me to teach this. Why are you in this class?
Okay, because this is a state law.
Because it's a requirement for what?
Graduate.
Not to graduate. You just need 3 years of math. You can take accounting
To go to a course.
to go to a 4-year school. So what you need to do is you need to call up the college admissions places and say, why do I have to take this to get into your school? And if you do that, what are they going to tell you?
I don't know. So
You honestly don't know? Casey?
We don't
We've already
need to.
talked about this so many times.
I know. So what's the answer?
It's not about what you learn, it's about how you learn it.
Right. And so what the colleges want to know is they want to make sure that you can handle complex problems, that you can figure this out, that you can handle some abstract reasoning things, that you're smart enough to stick with it and do a good job on all of that. So it's not that
What
you're
if
ever
it's
going to
just
use.
luck?
Well, I shouldn't say that it's not that you're never going to, because this will teach you some math, and that will teach you some math, that will teach you some math that you will use, maybe. Okay, but it's more about, like Casey said, learning to solve, complex problems. If you wanted to take a class that was full of math that you're going to use, what class would you take? Accounting or applied math, right? That's what those classes are for. Okay? So I know that's frustrating for you, and it's frustrating for me too. But the weird thing about education is that it works. That when you learn all this stuff and you go to college and you learn all that stuff, and the same thing happens in college. You're going to be required to take some classes in college that you will never use again. But you get that college degree and it turns you into a person that is smart and hardworking and you make money and live happily.
Thank you.
Yeah, like me, yeah.
Maybe you go to Spain.
Yes, sir.
We're totally off track right now.
Well, we're already totally off
Yeah, well, anyways,
Yeah.
so what's the difference between pre-calc and math analysis?
The old thing that we had going was that we had 2 different classes, pre-calc and math analysis, and the Helvenator taught this one. Hi, Brooke. Mr. Helvey taught the pre-calculus class, and that was for the sort of the college-oriented kids. You were able to get college credit for that class through Central Washington, okay? And then when you were done with that, then you were qualified to teach, to learn. Oh, I think she knows already. She's sitting at her computer rolling her eyes going, oh my God, will you guys be quiet so I can learn? And then this was the class that I taught, which was for kids that still wanted to have 4 years of math because they wanted to go to a 4-year school, but they weren't necessarily like a math-oriented person. But if you were a junior in this class, then you could still end up taking calculus, okay? Now, when Mr. Helvey snuck away in the middle of the night this summer and didn't come back, then we were in a little bit of a bind. And so we tried to hire a new teacher and we couldn't find a good one. And so what we did is we said, okay, we're going to take his classes and we're just going to farm them out. So actually there were originally supposed to be 3 advanced algebra classes this year. Remember we have 34 kids in here? There were supposed to be 3 of them, but then we just made them into 2. So we killed 1 class that way. Ms. Parkin is teaching an algebra class for the first time ever, so we killed the class that way. And then also what we did this year is we combined those into 1 class and killed the class that way. Okay? I think next year we're going to go back to having both.
Yay.
But the exciting news for you guys, and especially Colton, and this relates to what we were just talking about, is that I have had some discussions with Ms. Herzog and with Mr. Pugh, and we are no longer going to offer calculus. What we're going to have instead is statistics, okay? And the reason why we are changing to that is because the only college majors that need calculus are math and engineering, okay? Statistics you use in psychology, sociology, biology, even for like a nursing degree or teaching degree, you always have to take a statistics course. So it's a much more useful, okay, class for you to have that foundation when you go to college. My daughter's taking statistics in college right now, and she's a sociology major, okay? So maybe you'll find that a little bit more useful.
Now
in
that
your
actually in the discussion used for stuff, actually.
Right, yes.
So what's the difference between pre-calc and math?
So this is harder because it's college credit class, and this is a little bit more slower pace.
Is that what you're saying? I'm going to be that's our class then? Is that what you're saying?
I would encourage, if you are a sophomore in this class right now, for you to take pre-calculus. Because if you're a sophomore in this class, then you are ahead of the pace as far as math goes, and so that sort of makes me think that you have some sort of a natural aptitude for that. If you're a junior in this class, I would suggest that you take math analysis. If you're a senior in this class, hopefully I'll never see you again. Yes? Right, now we do it through the University of Washington instead of Central, but yeah. Statistics is just like calculus. It is an advanced placement class, and so you can take the AP test at the end of the year if you want to try that, and if you do well on that, then you can get college credit for that.
Oh, I have a question.
Okay.
You know how other classes, if they have college credit, you have to like pay in it, like a strong.
Yeah, right. So for this one, you have to pay to be, no, you don't have to, but if you want the college credit.
Okay.
But you can be in the class and say, I don't really want the credit, but you know what I'm saying? You have to get my approval. Oh, to get the college credit? No, they'll give you whatever. I think for the U, it's I think if you get a C, you still get credit, but you can't use it to move on to the next math class. So at the University of Washington, pre-calculus is math 120, and then calculus is math 124. And I think, yeah, you have to get a B or better in math 120 to move on to that. If you got a C in this, you'd have to retake 120 at the U and before you can take 124. But again, how many of you are actually going to take calculus in college? Probably. You were planning on it. Right. So you and me can sort of fry together because I really like using calculus. But it is honestly not very useful. It's my favorite subject. Yes.
You need 4 years of math.
You need 3 years to graduate,
Okay.
4 years to get into a 4-year university.
3 years too.
3 years is good enough. Okay, so what happened? It was you! I blame you.
So, Mr. Arnold, C in math analysis next year.
What grade are you in right now?
I'm a junior.
Okay, math analysis is probably the best choice for you.
That's what I'm thinking.
But pre-calculus, 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 pre-calculus,
Math analysis.
accounting.
That's probably what I'm gonna do anyway.
What do you mean not you, Casey? Why?
She doesn't want to lose.
Oh, come on.
She doesn't want to lose her dollar.
I don't think that you're joking, but I think that you can do better than this.
She doesn't want to lose her dollar.
Hey,
All right,
hey,
so
we're making
what?
those promises. I want to
What? That wasn't recorded. There's no evidence that happened.
That was
That one's gonna get mad at you and force you to get.
Right, Brooke will also be in pre-calculus next year. She's
Baby.
another one.
And so, O'Reilly, this YouTube video is going to go pretty public.
It's, well, by definition, it will be. All right, so back to the thing that we were doing before Colton screwed us up. So now this is exactly the same as the one that Dylan and I were working through together. What does this 2 do in front of the cube root? It multiplies all of the y values by 2. So this now, instead of being at 1, will be at 2. And this, instead of being at 2, will be at 4. This one, instead of being at -1, will be at -2. And this, instead of being at -2, will be at -4. Okay, hold on a second. I want to finish this problem. All right, now the +1 moves it to the left 1, and the -4 moves it down 4. So all of these points I would need to replot. Left 1, down 4, left 1, down 4, left 1, down 1, 2, 3, 4, left 1, down 4, and left 1, down 4. Okay? Whoa, that wasn't very good. So it'll look something like that. Okay? Yeah, I would at least graph these main points first. You don't have to connect the dots, but you can graph this, 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 and this first, and then shift them around from there. That's a good way to do it. All right, the one last thing in here, is sometimes this, I don't know, I wish I had candy every day. Can anybody, yeah, because I'd love to like ask a challenge question every day that's like the candy question of the day. If you get it right, you get candy.
Well, that's not my skills.
What is different about this function, this equation, than all of the other ones that we've graphed? Can anybody see it? What? What do you mean I can reduce that one?
There's a number from
Find the square root of
Yes. The +18 is inside the square root. Oh, we've done these inside. Okay, right. Okay, so it's kind of basically, I think Courtney would be the candy winner there because the 9 is in front of the x. Okay. All the other times that we've done these, the 9 would be, it would look like this. Okay. And so this is a little bit of a special case, right? We're going to factor that out. What you don't want to do is you don't want to look at this and say, well, there's a 9 there, so it's going to be a vertical stretch of 9 and then a shift to the left of 18, because the thing that tells you the vertical stretch is what's outside of the square root. And so what Courtney said is correct. We're going to factor out that 9, What am I left with if I factor out that 9? X plus 2. And now we know the square root of 9 is 3, so I can pull that out. And so it initially appears to be a vertical stretch of 9 and a shift to the left of 18 is actually a vertical stretch of 3 and a shift to the left of 2. Okay? And then you can also do the same thing with cube root functions. So if I start out with the cube root of 8x plus 32 minus 2, you might think, oh, that's a stretch of 8 and a shift of 32, but you would be wrong. What do I have to do?
Factor out the 8 and then minus 2.
Factor out the 8, so it'll be x plus 4, because 32 divided by 8 is 4. And then conveniently, we know the cube root of 8 is 2, so this simplifies down to be 2 cube root of x plus 4 minus 2. All right? So just make sure you're paying attention to that when those problems come. Okay, so we're not going there because we already did those, so we're going to start with, I think it's 20, is it 21?
Yeah.
Okay. All right. Anyone have any messages for Brooke before we say goodbye? Okay, Courtney. Okay.
Make sure she comes to the game.
Yeah, go to the game.
You can't go to the game if you're sick. If you
Okay,
miss
make
school.
sure she is going.